Hello everyone. Today we'll be talking about kinetic sand, which is a very interesting experiment that you basically make a do-it-yourself kinetic sand in this experiment. So what is kinetic sand? Kinetic sand is an example of a diluent or a non-Newtonian fluid that increases its viscosity under stress. Kinetic sand is sand that sticks to itself, so you can form clumps and mold it into your hands. It's also easy to clean up because it sticks to itself. So you're basically, in this experiment, we're creating a polymer, which I'll explain to you in the next slide. So the main polymer in the sand is polydimethylsiloxane, also commonly known as dimethicone, and it's found in hair anti-frizz gel, diaper rash cream, and a variety of cosmetics. I even went into my cabinet in the bathroom and saw that I had some anti-frizz gel on the back. It said that it had dimethicone on it, so it is very common in your cosmetics. So polymers. Polymers are repeating monomers and are a special part of life and everyday things. Polymers are in all types of things like plastic bottles, tires, and different gadgets. Polymers mostly describe the synthetic plastics, but also there are natural occurring polymers like wood, silk, DNA, cellulose, proteins, and rubber. So if you want to think of polymer, just think of it as something with a hydrocarbon backbone, and it's basically just carbon and hydrogen repeating in a very, very long chain. And if you think of DNA, it has a double helix with the A, C, G, T, different molecules all spinning around, repeated. That's what a polymer is. So that can kind of give you an image of what it is in your head. It's just a repeating monomer over and over and over and over again. Some natural polymers consist of hydrocarbons and isoprene, while other more complex polymers are composed of pentose sugars, nitrogen-containing bases, and phosphoric acids, i.e. DNA. Polymers are materials made of long repeating chains. The materials have unique properties depending on the type of molecules being bonded and how they are bonded. Some polymers bend and stretch, like rubber and polyester. Others are hard and tough, like explosives and glass. Polymerization is a process reacting monomer molecules together in a chemical reaction to form polymer chains or three-dimensional networks. So here's an example of organic polymers with a carbon backbone. You got the liver tissue. Also with the glycogen, you see right here how it's repeating. And even in plants, the leaf tissue here, you've got the starch and the cellulose, which is in the cell wall of plants, how it repeats. These are all naturally occurring polymers. Inorganic polymers have a backbone that consists of elements other than carbon, so it can be nitrogen, all kinds of things. So you have those in plastic bottles, bowls, plates, cups, toys, trash cans, bins, all kinds of things have that. So here's a visualization. And here's some more uses of polymers. So we can use them in grocery bags, soda and water bottles, textile fibers, phones, computers, auto parts, and toys all contain polymers. Polyester is one of the most common plastics and actively used in the packaging industry. Bottles, toys, containers, disposable glasses, TV cabinets, and lids are some daily use products that have polyester in it, and is also used as an insulator. So the most important use of the polyvinyl chloride is the manufacture of sewage pipes, and is also used as an insulator in the electric cables. So polyvinyl chloride is used in clothing and furniture and has recently become popular for the construction of doors and windows as well. It is also used in vinyl flooring, which is in your apartment sometimes, the artificial flooring. Urea formaldehyde resins are used in making the adhesive molds, laminated sheets, unbreakable containers, etc. So these are all different types of polymers that we use in our daily lives that we don't realize all contain the same thing and repeating elements over and over again. So very interesting. So the experiment. So materials that you need for the experiment is cornstarch, sand, water, dish soap, gel, oil, or something that has dimethicone in it. It could be anti-frizz spray, all kinds of things. So I did the experiment. It didn't quite come out as successful because it's kind of a ratio that you have to measure out of the exact amount of water, cornstarch, and dimethicone, etc. So mine came up kind of like a floopy little nasty kinetic sand. But I have a video here that will show you a better example of kinetic sand. So basically they have the water, the dish soap, they added some food coloring to make it pretty, mixed it together, a lot of stirring and mixing till you get that right texture. That texture is very important. So they add more cornstarch, basically trying to get that good sandy texture. And now see how moldable it is. You can put your fingers through it. It's very good. Looks like kinetic sand. They did a very good job on that one. So now they're showing how you can slice it, mold it. All these are properties of polymers and how it bends to the will of whatever you want it to do. So very simple experiment that you could do in your house if you would like to make something very interesting. It's fun to play with for people that like to hold and mess with things in their hand. So in conclusion, kinetic sand is an interesting experiment where you turn sand into a polymer using common household items. It will possess the common characteristics of a polymer like flexibility and the ability to easily be molded and stretched and all kinds of things. Polymers, like I said, are used in everyday common things. I won't go over those again. There are synthetic and naturally occurring polymers, and the experiment basically had us mixing the required materials with a certain ratio to create a thick, wet, easily moldable polymer called kinetic sand that is just fun to use. And here are the references that I got my information about polymers, kinetic sand, and all types of stuff. So just check it out, and thank you, everyone.